This is 75 Arlington Street, Lesson 2. Working directly on my computer here. Having copied down. Okay, so we start up Revit, and this is generally how we deal with storefront conditions. What's storefront condition? Where most of the interface between the building and the street is glazing. I'm going to start as if starting a new project, right? Well, I am starting a new project. So new project, oops, not open. New project. Always start not with a construction template because it creates unnecessary levels, but architecture template. So it only creates level 1 and level 2, default level 2 at 10 feet. Okay. So here's the first floor plan. I'm going to import a floor plan of Arlington Street here. The AutoCAD file is a bit messy, but we'll just bring it in and insert menu, link, AutoCAD, documents, there's AutoCAD, pretty sure that's it. Taking some time to link that, I'm not sure why. It's not a very big file. What it does after it imports the link to the AutoCAD file is it pins it in place. It's unpredictable where it will put the file because it tries to align by default whatever it thinks the origin of the drawing is. Okay. You can ignore errors associated with proxy objects. So that all that means is that somehow this was probably prepared with AutoCAD architecture desktop. So it has some 3D elements like walls and stuff built into it. So there's a CAD drawing, and you can see that it's pinned, and we have to unpin it in order to move it. This is an outline of an upper floor. It doesn't have the ground floor drawing, so consider that. I'm moving but but it's a good outline for the perimeter walls. A better drawing for the ground floor we saw in the previous video, though we only have an image of it. We don't have vector graphics form. Let's save this file. Save this project, which we haven't done yet because we started a new one. Because we're using Revit 2018. So, what do we have so far? We have a first floor plan with an underlay. We have elevation markers, a couple of which are buried behind the drawing here. We'll take care of that in a minute. So if I go to this elevation view, the south elevation, you can see that all we have in the drawing is level 1 and level 2. Now you remember, we know the floor-to-floor height. We determined that by examining a drawing, which we could import as an image here, would be the, I think it's the second page of that drawing. Right. It is not to scale, but it's easily scalable. How do you scale an image in Revit? Well, you take what is a known dimension, measure it, and then you type what the actual dimension is. This is a good example because we have 15 and 13 feet drawn at scale, and we can, so 13 plus 15 is 28. We can resize this image and measure, right? So I'm measuring from here to here. It's supposed to be 28, and it's actually more than 80 feet, right? So here's what we do. We click start and end point, and then type 28. So now when we measure, there's a few things I can do with this. I don't need to. Everything I need to know I've already explained. But if we wanted to, we could align level 1 and then select level 2 and make that, just type in a value of 15, and that moves it to where it belongs. So the 18.6, again, those are absolute elevation bullets taken from sea level. What we care about is the floor-to-floor height, because if we're modeling the first floor, we need to know what at what height the underside of the floor above is going to be. Let's go back, Control Tab, first floor plan. How are we doing on time? I can't see it. So, how do we model this building? It's easier than it appears, and I'll explain. There's a couple strategies that we could use. But basically the idea is you want to model the perimeter with a single wall thickness and then develop all these exceptions to that wall thickness as articulation of the building shell. So I could measure, for example, I'm going to take, let's say I used as a thickness let's take the aligned dimension here and measure from here. I've got 3 feet thickness at some point in the building shell. And let's say, so I'm going to take a wall. Usually I go exterior face of wall around the building. In this case we have a better notion of, we seem to have lines of the interior face of the wall. Well, let's use exterior. And then we proceed in a clockwise direction. I'm going to edit type here to create a new duplicate and call this a generic 36-inch wall. And edit the structure of it, so we'll assign a thickness of the material, the default material, with 36 inches, 3 feet. Okay. Okay. The location line we want to use finish face exterior. Base constraint is level 1. Top constraint is going to go up to level 2, so the wall will be 15 feet in height. See, it's grayed out there. You can type over it. Start. Usually start at top left. I'm going right around the perimeter of the building. Snap to the endpoints. I'm not going to try to mess with this little nook. So what I'm going to do here is approximate where that intersection is and continue in this direction. It should give me an endpoint. In anticipation of that, I should have probably have drawn a line around that. So anyway, I go to that corner and I'm going to go to the corresponding corner on the other side. We can align these afterwards as we need to. You don't have to draw it all in one go. See, the CAD file is not very good. It's got some holes in it, so I'm just snapping to whatever I find there. There it is. So if I go to a default 3D view, let's examine what it is that we have. see our AutoCAD mess, and somewhere in here is what we have of the building shell so far. Is it there? Not sure why I can't see it. Let's turn on shadows. That should. Oh, boy. So we drew that over here. Okay, so in the next lesson, if I select any one of these walls, you see that they go finish face exterior, level 1 to level 2. And then next lesson I'll show you how we're going to deal with the openings.